Hello everyone, welcome to the next session on operations research. In this session, we will take up another numerical on the topic of dual simplex method. Use dual simplex method to maximize z, which is minus 3x1 minus 2x2, subject to these four constraints, and the last one is the non-negativity constraint. So we will take up the first step, in which we will not convert the problem into any other type. We'll leave it the way it is. We will first talk about the constraints. Since it is a maximization type of problem, the constraint should be of less than equal to type. The first and the third constraint are greater than equal to. So I'll write in the first step, that is multiplying constraints 1 and 3 by minus 1 on both sides. So the first constraint becomes minus x1 minus x2 less than equal to minus 1, and the third constraint becomes minus x1 minus 2x2 less than equal to minus 10. So the second step, I will rewrite the problem as maximize z, which is minus 3x1 minus 2x2. It is subject to the first constraint is minus x1 minus x2 less than equal to minus 1. Second one is x1 plus x2 less than equal to 7. Third one is minus x1 minus 2x2 less than equal to minus 10. And the last equation is x2 less than equal to 3. And then I'll write down x1, x2, x1 and x2 are greater than equal to 0. There are only two variables. Then I'll go for step 3. Now I'm going to convert the problem into standard form. So this is maximize z minus 3x1 minus 2x2. It is subject to, now the first constraint you can see is less than equal to. So on the left hand side I'm going to add plus s1. For second one plus s2 plus s3 and plus s4. So I will write down minus x1 minus x2 plus s1 is equal to minus 1. Second one is x1 plus x2 plus s2 is equal to 7. Then it is minus x1 minus 2x2 plus s3 is equal to minus 10. s2 plus s4 is equal to 3. And lastly x1, x2, s1, s2, s3, s4 all are greater than equal to 0. Then I'll go for step 4, where I'm going to find the initial basic feasible solution. For that I'll put x1 and x2 as 0. So therefore s1 becomes minus 1, s2 is 7, s3 is minus 10 and s4 is 3. You can observe s1 and s3 are negative, which means the solution becomes infeasible. So I write down, since s1 is less than 0 and s3 is less than 0, therefore solution is infeasible. So I will be using dual simplex method, which is proved from this step. So I'll make the initial dual simplex table. Here I'll have x1, x2, s1, s2, s3, s4, and then the column of solution. Here I'll write down the coefficients of the equation of z. Here I'll add plus 0 S1 plus 0 S2 plus 0 S3 and plus 0 S4. So I'll write down the coefficients of each of them over here. It is minus 3, minus 2, 0, 0, 0, 0. The basic variables are S1, S2, S3, S4. The coefficients of each of them in the equation of Z is 0. So I'll figure out what is Zj and Cj minus Zj. Now I'll write down the coefficients of each of the equation from here. Minus 1, minus 1, 1. These are 0 and this is minus 1. Then we have 1, 1, 0, 1, 0, 0, 7. Minus 1, minus 2, 0, 0, 1, 0, minus 10. And this is 0, 1, 0, 0, 0, 1, 3. Now I'll multiply this CBI value into each of these terms over here and add them. Since all 4 are 0, these will also turn out to be 0. Now I'll calculate Cj minus Zj. So this is minus 3, minus 2, 0, 0, 0, 0. These two values are negative for making the problem optimal. But here we have negative values. So I will take up the minimum negative value. So it is minus 10 over here. So S3 will leave the solution. This is a leaving variable. Now I am going to calculate Cj minus Zj upon Aij, that is of the key row element. So this becomes minus 3 by minus 1, minus 2 by minus 2. These are 0. Now here the minimum value is 1. So x2 is going to enter the solution. So I will write down x2 is the entering variable and s3 is the leaving variable. So now we'll go for iteration 1, that is step 5. Draw the table again. Here I'll write down S1, S2, X2 and S4. The coefficient of S1, S2 and S4 are 0. Coefficient of X2 is minus 2. So we will start with the key row, which is the third one. I'll divide each element by negative 2, and by now we know that the elements above and below the key element, that is minus 2, will also be 0. So this will be 1 by 2, 1, 0, 0, minus 1 by 2, 0 and 5. Here these two elements will be 0 and this third one will also be 0. Now I'll calculate the rest of the elements. I'll show you one of them. Suppose if I'm calculating with the first one, this is minus 1, original element, minus corresponding key column, that is minus 1, corresponding key row, that is minus 1. So minus 1 into minus 1 divided by the key element, that is minus 2. So this is minus 1 minus, this becomes plus and this also becomes plus. So the value is just, so when you solve this, it is minus 1 plus half, that is minus half. This is the first value. And correspondingly, you can calculate the rest of them. This is half, minus 1 by 2. This is 1, 0, minus 1 by 2, 0, 4, 0, 0, 1, half, 0, 2. Then I'll calculate Zj. I'll multiply the third row with minus 2. So this becomes minus 1, minus 2, 0, 0, 1, and 0, and this becomes minus 10. Finally, I'll calculate Cj minus Zj. Minus 3 plus 1 minus 2, 0, 0, 0, minus 1, 0. And if you observe, still there is one value minus 2. So S4 has to leave the solution. If S4 is leaving the solution, who should enter the solution? So Cj minus Zj upon Aij. I am going to divide each element of Cj minus Zj by each element of the fourth row. So minus 2 by minus 1 by 2 is 4. This is 0, 0, 0. This is minus 2 and this is 0. So once this is done, we can see that there is only one positive value here, as we don't consider the negative ones. So x1 has to enter the solution. So I'll write down x1 is the entering variable, and S4 is the leaving variable. I'll go for step 6, iteration 2. Here I'll have S1, S2, this is already x2, this will be now x1. These two are 0, this is minus 2 and this is minus 3. Now I'll write down these values again. I'll first start with the key row. I'll divide each element by minus 1 by 2. So this becomes 1, 0, 0, 0, minus 1, minus 2 and 4. These corresponding values will be 0. Then I'll calculate the rest of the values. Here I get 0, 1, 0, minus 1, 6, 0, 0, 1, 1, 1, 0, 1, 0, 0, 0, 1 and 3. Now I'll calculate Zj. I'll multiply minus 2 into 0 plus minus 3 into 1. So this becomes minus 3, minus 2, 0, 0, 3, 4 and this is minus 18. Then I'll calculate Cj minus Zj. It is 0, 0, 0, 0, minus 3, minus 4. Now you can observe that all the values in the column of solution are positive. So I'll write down, since all Cj minus Zj are less than or equal to 0, which is the condition required for maximization type of problem, and all values in the solution column are positive, therefore optimality is reached. And solution is also feasible. So therefore I'm going to write the optimal solution now. The value of x1 is 4, value of x2 is 3. You can see over here. And the value of z max, that is over here, minus 18. So this is my solution. If you want, you can substitute x1 and x2 in the equation of z, that is minus 3x1 minus 2x2. So this becomes minus 12 and minus 6, that is minus 18. Hence you can also tally the solution with the given equation. So with this I end the session. I hope you have understood the numerical on the topic of dual simplex method. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.